Welcome everyone, my name is Mr. McGregor, and in this video we're going to be looking at power. This is the last video for Year 11 Mechanics. By the end of this video, you'll be able to define the term power and use the formula power equals work divided by time to calculate power, work, or time. So what does power actually mean in terms of physics? Because it's one of those words we use in everyday life but doesn't necessarily match up with the physics definition. Here are two engines. On the left you can see the largest combustion engine in the world, which comes out of a whopping great big ship, and it generates 80,080 kilowatts of power. And on the right you can see the engine from a car not too dissimilar from mine, and it only generates 74 kilowatts of power. So which one would be able to do more work? Well, for an example, let's have a look at this situation with the crane. Let's say the crane is lifting a fully loaded shipping container with a mass of 24,000 kilograms, and it's lifting at a distance of 25 meters. We can use our gravitational potential energy equation to calculate the amount of energy it's doing, which is 6 million joules or 6 megajoules. So which engine will be able to do that amount of work? Well, in actual fact, they can both do the same amount of work. The difference is how quickly they will be able to do that work. The Polo engine will do it, but it will take a long time. The ship's engine will definitely do it, and a lot faster. So the power equation is equal to work divided by time, and that makes sense because power is a measure of how quickly a machine can do work, so it's got both work and time in it. Power is measured in watts, capital W, not to be confused with capital W meaning the work done, measured in joules, and that is equal to the change in energy, also equal to the force times distance, and check out the work video if you need to revise that. Time is measured in seconds, and this is our magic triangle. One other point to note is that 1 horsepower is equivalent to approximately 750 watts, and that's an old unit for power. I'm now going to look at two examples. The first one is an achieved level example, and the second one is excellence. You can choose to watch one or the other, or both. Firstly, the achieved level example. Jeremy lifts a 15 kilogram box 1.2 meters onto a bench. How much work has he done? Well, we start with our work equation, which is equal to the force times the distance. But we haven't been given a force directly, there's nothing there in newtons. But we can use our mass of 15 kilograms, multiply that by the strength of gravity to get a weight force of 150 newtons. We put that into our work equation, multiply it by the vertical distance, and we get 180 joules worth of work. If he takes 3 seconds, what was his power? Well, we simply use the power equation, which is work divided by time. We substitute in the work value, we divide it by the time, and we get an answer of 60 watts. I'm going to do two examples. The first one is an achieved level example, and the second one is an excellence level example. So here's the first one. Let's say Jeremy lifts a 15 kilogram box 1.2 meters onto a bench. Part A, how much work has he done? Well, we're going to use our work equation. Work equals force times distance. But we haven't actually been given a force. There's nothing there in newtons. But we know the object's mass, so if we multiply that by the strength of gravity, we get 150 newtons, its weight force. We can then substitute that value into the work equation, multiply by the vertical distance 1.2 meters, to give us 180 joules of work. Question B. If he takes 3 seconds, what was his power? Well, we're going to use the power equation. Power equals work divided by time. So we use the work value we calculated, 180, divided by 3 seconds, gives you 60 watts. Question C. Fred has a power rating of 95 watts. So how long would it take him to lift the box? Well, we're going to use So, where on earth do you start? Well, let's have a look at the numbers we have been given. I note that I've got here a power and I've got a time, and I know that both of those things are in my power equation. So, let's find the third thing in that equation, which is to find the work. So I simply plug in my power and my time, and I see that it's done 150 joules of work. The question is, what does that value really mean? Well, in this case, the crane is lifting up an object, and so it's transferring gravitational potential energy to that mass. Work is equal to the change in energy, so the change in energy of the mass must also be 150 joules. And if I know the amount of gravitational potential energy it's got, I can rearrange that equation to find my mass. So now you can define the term power, and you can use the formula to calculate power, work, or time. Thanks for watching.